Hey folks, welcome back to AI Unplugged. I'm your host, Travis Freisinger, and today we're delving into the fascinating world of vibe-based evaluation, an intuitive approach to working with AI that might feel more familiar than you think. We'll explore how this method aligns with some key practices in TD or test-driven development, and why both are powerful tools for iterative development. As we go deeper, we'll discuss how you can evolve beyond vibe-based methods with the help of advanced tools like Langsmith and FreePlay, otherwise known as LMOps tools. So, whether you're an AI enthusiast or a software developer, there's something in this episode for you. Let's jump in. So, what are evals and why are they important? Well, when we talk about evaluations or evals in the context of large language models, we're referring to the methods and metrics used to assess the quality, accuracy, and relevancy of the responses generated by these models. Evals are critical because they help us understand how well a model is performing, uh, guiding improvements and ensuring that outputs meet the desired standards. So very similar to like TDD, at the very least, the tester ensuring that the system behaves the way we expect it to. There's more to unpack there on being a thinking tool. But in the world of large language models, LLMs, which are AI systems trained on vast amounts of data, text to generate human-like responses. Traditional metrics like accuracy don't always capture the nuances of that interaction, especially considering that it's based on human language. So this is where subjective measures come in, whether the response feels right or meets our expectations. These subjective evaluations are what I'm referring to as vibe-based evaluations. Essentially, it's about trusting your gut on whether the AI's output meets your needs, especially when more empirical data isn't available. So just like in TDD, building an eval suite takes time, and you're often going to start trusting your gut, trying to drive that way. Let's dive in a little bit to understanding vibe-based evaluations. They might sound informal, they might sound kind of like, oh, that's not real engineering, but they're a critical part of how we interact with AI and kind of early stage software systems that we build out. As highlighted in the article in Defense of Vibe-Based Evaluations, link in the description, these evaluations are based on our gut feeling about whether a response feels appropriate or meets our need. Like there's kind of an intuitive aspect that we're leaning into here. This approach is useful for in the early stages of AI development when it's hard to define high quality responses empirically. If you've ever tried to build an eval suite for prompt, you'll understand there's a lot of friction to get going here. And sometimes, and what I'm advocating for is that leaning into the more vibe based, just kind of roll with it, see how it feels is often where we start. And that's okay. It's absolutely okay. We often start by trying things out and seeing how the LLM responds, which may seem unscientific, like I said, on kind of engineering focused, but it's natural and a practical way to begin evaluating AI. So you can do this with your own just chat experience. Chat, chat, chat. Oh, cool, look at that. It didn't give me anything close to what I'm wanting. Refine, maybe start a new session. It's the same experience. You're kind of going off your intuition. You know what you want based on what you're asking. Does it seem relevant? Now, obviously, it's scale. That's where it starts to become less practical. But to get the ball rolling, to get moving, absolutely. So it's just how similar to when you review a piece of code that just makes sense, or when there's something that feels off. Maybe you can't immediately identify like why it's super clean or why there's a funny smell that's giving you problems. Those are the vibes. That's that initial sense that's kind of guiding your approach, guiding your interaction here. I've talked about TDD. How does it line up? Well, let's take a look at the fake it green bar pattern. So let's take a step back and talk about this key concept in software development, specifically within TDD. So for those of you that are not familiar with TDD, it's a methodology where you write a test first for your code before actually writing the code. It seems bizarre and unintuitive to those that are uninitiated to the concept, but at the end of the day, once you get comfortable, once you understand it, it makes a lot of sense. I didn't come up with this idea. Kent Beck did. I've just invested a lot of my efforts and energy as a professional over the years understanding it, building TDD training courses, training people, building a website, TDD Buddy, link in the description, all of that fun stuff. So I feel like I may not be the creator of the concept, but I'm pretty well versed in its universe. So the idea is, we create a series of small incremental tests for the code that we got to go about implementing the code to make it pass. So this approach ensures that the code works as intended from the outset. It helps us catch bugs early in the process, and most importantly, it serves as a powerful thinking tool. It allows us to decompose a large problem into smaller, incremental steps that help guide our thinking, ultimately resulting in a far better solution than if we just magicked one giant thing up out of thin air, no matter how many times we've built it and put it together. It's going to force us to think in a more decoupled, modular way. So this foundational pattern comes from the foundational pattern Fake It, comes from a book by Kent Beck, Test Driven Development by Example. So the Godfather, the OG of TDD himself, and I believe it was one of his initial books, and it's buried in there in a section on green bar patterns. I've got some extended thought beyond what's in the book on my TDD Buddy website. Link in the description where I kind of dive into some sub patterns. A few of them provide a little more detail. So if you're interested, go check it out. If you're not, I'm going to walk through a real simple example of how Fake It works. So you start with a failing test. You're going to have written the test. Let's say we're writing something for the FizzBuzz Karta. Various inputs return fizz or buzz or fizz buzz. If you're not familiar with it, go look it up. It's a pretty popular Karta. Since the code isn't written yet, the test is going to fail. So let's say we're doing like if the value of 3, it return fizz. Like that's what we're checking for. So if 3, I'm expecting fizz. So now I'm going to go write some code to make that happen. And, I could be the really, I'm going to really draw my code out type of engineer, and I know exactly the abstraction I need. Don't go there. There's a pattern called the obvious pattern, and that's a trap you're falling into. Obvious things are never as obvious as you think they should be. So what I'm going to do here, in the interest of taking really small steps, trying to understand this problem that's new to me, pretending it's new to me, I'm going to go in and just write a line, if value equal 3, return fizz. Yep, it's hard-coded. It is absolutely non-scalable, but you know what? It's going to make that test pass. And then it's going to allow me to think about the code I've written, see if there's any generalizations at that point, not in my head before I've put the contents of my mind onto the screen for the computer to understand. I'm going to get it out and then rationalize about it. And that's, I think, the inverse of what most people are used to, rationalizing it and then producing. That, for me, is really the secret to this. So I'm going to build up this small suite of tests. Now, obviously, you can't just make Fake It test forever. It's going to be a super brittle, hard-to-change type of system. But the idea is it allows you to kind of put down some inputs to think about generalizing the pattern that you're seeing, exploring the structure, ensuring it's robust and maintainable. That thinking tool piece. So you start off by the vibes, the faking it, like, oh, I need this response. Don't know the algorithm, don't know how to scale this, don't care about any of that. I'm just trying to understand this small interaction here. So as I've said, TDD is more than just a method for catching bugs. It's a powerful thinking tool that allows developers to evolve the architecture and design in the software in a modular and decoupled way. I cannot stress that point enough. Because you're making small incremental changes and immediately seeing their impact through tests, you can reflect on each decision and feed that back into the process. This iterative approach not only improves code quality, but also encourages a system thinking mindset, where every part of the system is considered in relation to the whole. Super important in modular decoupled software systems. You have to think about the larger impact. Maybe that's the downfall of just unit testing, is it's very isolated. Integration, end-to-end, whatever you want to frame it as, it starts to break out and, cross dependencies, starts to get a little more systems approach. Then there's the whole mock versus no mock, versus stubs versus, there's a whole subsection of thought around that. I'm not going to get into that. That's outside the scope of this. But TDD exemplifies systems thinking in action. It allows developers to see how small decisions affect the larger architecture, helping them build systems that are both flexible and resilient, in a way that mirrors how vibes-based evaluations work when interacting with LLMs. Just as you start with a simple test in TDD, you begin with an intuitive vibe-based judgment when evaluating LLM outputs. Both approaches allow for incremental improvement and to build trust over time. Both is the engineer building trust in the system and maybe the larger team. So whether your code is interacting with an LLM or you're trying to write tests, you're trying to do both, it's all about those small improvements rolling that knowledge into the thing you're working on to help further refine. So, there's benefits and challenges with vibe-based evaluations. The benefits being they allow for quick, intuitive judgments that can guide early-stage development and build user trust. Maybe the user here is the engineer, not necessarily the end user, really trying to understand the thing you're working with, right? For example, when customers interact with an LLM, they typically don't run through a detailed evaluation process. They rely on their gut to decide if the response meets their needs. Same thing as an engineer. Getting in, playing with the tech, I'm relying on my gut to kind of drive my decision making around, is this working or is it not? And however, there are challenges. First impressions can strongly influence future perception. That's why I really think it's important to document and put it in a suite, regardless of the kind of probabilistic output that you're dealing with. And feedback from vibe based evaluations can lack nuance. That's why it's important to balance this vibe based approach with the more structured empirical methods. It's about starting at the vibes, ending at the engineering as you move forward with more mature LLM development. So, how do we move beyond vibe based evaluations? It's great to get going, it's great to kind of break that initial friction to move forward on an idea, but ultimately we know it's not going to scale. So the key to transitioning from intuitive judgment to structured empirical approaches is, important. Not just like in TDD, it's about building a robust evaluation framework, and that requires effort. It's not going to just magic itself into existence because you put a few tests down. You have to continually build it out, maintain it, groom it. It's another thing that this is really where the engineering meets the LLM, right? Like it's that ability to ensure quality in the output that we. So we got to actively build and maintain these eval packs, a set of tests. Think of it that way, in a systematically and thoughtful way. It's going to assess the LLM's performance. You're going to want tooling to get into this space. I do believe there are techniques and where the prompts are just in text files and they're shoved next to you, and maybe there's more of an eval. I know there's like an eval driven development type framework out there where you can kind of TDD it out. At the current point in time, I'd say that that's more a tools problem. I think we've gotten to the point where there's observability and these evals are so tightly coupled that you want a tool. You're going to want something like Langsmith or FreePlay to help manage this process, to help have a central location for all of these things. And the reason being is that as this concept scales, so even though I'm working on a small little tool called Scribe AI, I know I got to put a product tag on when I think evals versus an engineering hat. I'm more worried about the observability from an engineering perspective than I am about the experimentation and the tuning than I am from more of a product perspective. And I think over time that becomes more of a product and design concern than a raw engineering concern. Engineering can pick up at the embeddings, the semantic search, like full text search, that type of concept. There's still plenty of engineering space to be involved. Evals just feel like one of those things that we need to be aware of, but we really should be leaning into at least a product or design mindset, potentially handing that off to someone who's a little bit more familiar. Anyway, so if you got a tool, it's easier to do that than things being in the code base. It's going to help integrate these evaluations into the development pipeline. And I like to call these LLM ops tools. And so those who are not familiar with the LLM ops term, that refers to the practices and tools designed to manage, deploy, and monitor large language model and their pieces in production. So we're not building LLMs necessarily. We're not building models at scale. We're not the Apples and the Spotifys of the world. At least I'm not at this stage. So the goal is to be able to monitor the artifacts that interact with these systems. Think about an observability for your database. You still have spans to check the code and the queries that are going in. So these platforms I feel are essential for keeping our AI infrastructure running smoothly and ensuring the performance we expect over time. I alluded to this, experimentation and prompt tuning. So, getting a prompt out, there's a lot of work that goes into iteratively refining and making sure that it's there. And once it's there, that's where the vibes end, right? You kind of know this is the space you want it to operate in. It's time to start building that proper eval pack to kind of ensure that it's operating the way you want to. Prompt. So that's that prompt tuning concept. So as developers or designers or product managers or owners, I'm really trying to outline the different roles here. We have to need to tweak prompts to optimize LLM responses. Now, I would say the optimization and the formatting is an engineering concern. The prompt, the larger picture of the prompt, is something that really should be done with a product or design person. It's more in that category. So prompt tuning involves adjusting the inputs to the prompt. Could be adjusting the actual prompt text, the way things are structured, the system prompt, the user prompt, maybe chaining them together using different prompting techniques. These are all things that fall into the prompt tuning arena. For example, changing a prompt from explain recursion to explain recursion with an example in Python can lead to a much clearer and more relevant output from the model. You're giving it a more constrained ask, right? Just like if you go and talk to a person and say, I need help, their initial response is likely to be, you need help with what? But if you can say, hey, I need help understanding recursion and I'm working in Python, obviously assuming they're a developer and they have the knowledge, they'll be able to come answer your question in a more directed way or point you towards a resource that will help you understand that. Maybe your colleague Jane really understands recursion in Python. I could say, go speak to Jane about that. She's an expert. Take 5 minutes of your time and learn what you can. Awesome. Great. It's that directed inquiry that I'm able to work with. So same thing applies to LLMs. So to platforms like Langsmith, FreePlay, there's a whole other variety out there. These are the two I'm playing with. Provide the structure needed to compare different prompts. I can compare prompts, the same prompt in different models like Claude versus Llama versus OpenAI. I can literally run it and compare model versions and see. So I might find that I don't want to just lean into OpenAI. Maybe Claude's really good at these certain types of responses, and I really prefer its output. I can make that tweak there. And that's the other thing that needs to be managed with these LLM ops tools is the model needs to be embedded next to the prompt. I really believe that. I don't want these magic strings floating around that I have to. There's just too much variance there for me to be comfortable in this already highly variable space, ensuring that I'm engineering things well. Let's see here. So, so by having a structured approach, we can measure the impact, we can refine, we can build test suites of sorts. I think some of them have the test suite language from the evals. It's really a data-driven approach to ensuring that, kind of each iteration brings us closer to the desired outcomes. It's much like running experimentations in a scientific context. And the nice thing is once we've experimented, we can lock our experiment down with our eval suite, and we can push that to at least a CI pipeline. Potentially, real-time observability on some of these platforms. They're going to send me a page if things go too far out. But that does take time, right? That is a very deep exercise in both design and engineering and kind of the overlap of that space. All right, so talked about evals, vibe-based evaluation, a little alluding to integrating them into kind of larger development. So, I can't emphasize enough how much these tools are important to scaling beyond kind of these initial vibe-based judgments, scaling out beyond 1 or 2 developers into a full-fledged product that can be supported. You've got to define the metrics, whether it's coherence, user satisfaction, brand voice, whatever you're working with that makes sense. And then I really stress using an LLM ops platform to automate the evaluation process, to offer an experimentation framework, to offer kind of version control management around your prompts as you test them, ensuring that they're tested, they're updated, they're version controlled, they're following all the best practices. So think about it as a test suite. It ensures that the LLM can handle real-world variability and continue to meet expected user needs. By combining these vibe-based evaluations with more mature structured methods, you can create a comprehensive framework that guides your prompt development in a way that aligns to your product needs. So that's a wrap on today's deep dive into vibe-based evaluations and how to evolve beyond them. Remember, building a robust evaluation framework is like creating a test suite in TDD, essential for ensuring quality and continuous improvement. Which evaluations are you most excited to try? Have you given it a shot? Do you know some better LLM ops tooling out there? Let me know in the comments, and stay tuned for the next episode of AI Unplugged. Not sure what it's going to be yet, It'll probably be something related to my experimentation with Scribe AI. I've got a few things I think I want to talk about there, but stay tuned. Definitely going to be about AI. So thanks for tuning in. Don't forget to visit my blog at aibuddy.software and follow my live streams at GPT with me on YouTube. And until next time, keep experimenting and stay curious.